Welcome back to Talk Tensors, everyone. Today we're diving into MiniMax-01, Scaling Foundation Models with Lightning Attention. It's a paper that's really changing what we think is possible with large language models.
Yeah, it's really exciting. It's really addressing this challenge that researchers have been hitting up against, for a while now, how to get AI to remember, more analyze larger amounts of information at once.
Right, and thinking about this practically, like you're an analyst and you're trying to analyze some massive legal document or a huge code base.
Yeah,
It's like you're trying to read this book through a tiny little peephole.
exactly.
Yeah.
And that's really been the limitation, right? That context window, the amount of information that the model can look at one time has been really limited. And MiniMax-01 is trying to blow that wide open handling up to 1 million tokens during training and then up to 4 million tokens during inference, which is just mind-blowing.
Wow. That's incredible. So we're going from like a peephole to this panoramic view.
Yeah.
What is enabling this? What's the magic?
Well, the secret sauce here is something called lightning attention. It's a super efficient way for the model to focus on the most important parts of the input.
Okay.
It's kind of like if you imagine a spotlight highlighting the key information,
Yeah.
and that makes it much faster to process these huge amounts of text.
I see. And it's not just about speed, right? The paper also mentions something called a mixture of experts, or MoE.
Oh, that's right, yeah. So instead of having one model trying to do everything, it's like having a team of AI agents, each one specializing in a particular task.
Uh-huh.
So they kind of divide and conquer, which makes the whole system more powerful.
So it's like a team of experts coming together to solve a problem.
Exactly.
Okay. So we've had this revolutionary architecture, but does it actually deliver? What were the results when they actually tested it out?
Well, they really put it head to head with the top models like GPT-4 and Claude 3.5 Sonnet.
Wow.
And it matches their performance on different tasks, but with this context window that is like 20 to 32 times larger.
So it's not just keeping up, it's surpassing them in terms of how much you can take in and remember.
Yeah, exactly.
That's amazing. But I'm guessing building this wasn't a walk in the park.
No, not at all. All the existing tools were designed for the older attention methods.
Right.
So it's kind of like they had to reinvent the wheel.
Uh-huh.
It's like, you're trying to build a skyscraper with tools that were meant for huts. They needed totally new techniques.
I see. So what were some of the key innovations? Give us a glimpse into these new tools that they had to create.
Sure. Well, one of the big hurdles was this thing called routing collapse. It's where you have a team, but only a few members are actually doing all the work.
Uh-huh.
And they solve this with a global routing strategy, which makes sure that all of the expert networks are contributing equally.
You want everybody pulling their weight.
Exactly, yeah. And then another challenge was, just handling this massive amount of data. So they use this technique called data packing, kind of like stuffing a suitcase really efficiently. So instead of filling it with a bunch of unnecessary padding, they concatenated different training samples together, and that minimized wasted computation.
So they're being very clever about how they're using their resources and how they're actually training the model.
Yeah, exactly.
So that's the training process. What about on the other side when the model's actually being used, like you or I are giving it a prompt?
Right. So inference, or how quickly the model responds, that's really important in applications.
Right.
They optimize that using these techniques like batched kernel fusion. They're basically combining multiple tasks into one, so it's faster processing.
I see. So it's like streamlining a recipe, fewer steps, faster results.
Yeah, exactly. And then they also kind of separated out how the model handles long versus short sequences,
Mhm.
kind of like having dedicated lanes on a highway.
Makes sense.
Yeah.
And then they also mentioned this thing called multi-level padding.
Oh, yeah. So instead of having this fixed padding, they dynamically adjusted it based on how long the input was.
I see.
So again, minimizing any kind of waste.
Okay, so it sounds like they really squeezed every ounce of performance out of this model.
Yeah, they really did.
But MiniMax-01, it's more than just text, right?
Yeah.
They also built a vision language model, MiniMax-VL-01.
That's right. They're taking this incredible language capability and adding the power of sight.
So it's like teaching AI to see the world.
Yeah, exactly.
That's amazing. How did they manage to train a model to do both of these things?
Well, they used a bunch of different data sets, images with captions, descriptions of images, question and answer pairs,
Okay.
that kind of thing. So that helped the model learn to connect the words with what it was seeing in the images.
So they're not just showing it pictures. They're actually teaching it to reason about them and answer questions about them.
Exactly. Yeah. That's really what makes it so powerful.
That's incredible. Combining these two worlds, though, I imagine that must have presented some unique challenges.
Oh, absolutely. Yeah, one of the biggest ones was this idea of modal alignment, making sure that the visual and language parts were kind of talking the same language, so to speak.
Right, because you don't want the AI to see a cat and think it's a banana.
Exactly. Yeah.
So how did they solve that?
So they used this four-stage training strategy, and they kind of built upon each step.
Okay.
So first, they fine-tuned the model on image data just so it could process visual information effectively.
Okay.
And then they moved on to, more complex visual reasoning tasks, things like object detection, image captioning.
So it's kind of like taking it step by step from the basics to the more complex stuff.
Exactly, yeah. And then the next stage was really about making the AI's responses more human-friendly.
Okay.
So, teaching it to respond to natural language queries in a way that made sense to us.
So it's not just about being accurate, it's about communicating effectively.
Yeah, exactly.
So what was the final stage?
In that final stage, they use something called direct preference optimization. It's basically where they gather feedback from humans on what kind of responses they preferred, and they use that to refine the model's output.
So they're really training the AI to give us what we like to make it a helpful and intuitive tool.
Yeah, exactly.
Yeah, that's fascinating. So we end up with this model that can analyze images and documents, understand complex questions, and even generate creative responses that combine text and visuals.
Right, and it's all built on this foundation of MiniMax-01, with this really groundbreaking architecture and efficient training process.
Yeah, we've covered a lot of ground here exploring all these innovations that make MiniMax-01 so remarkable.
It really is a big step forward.
But to really appreciate it, I think we need to understand the journey that got us to this point.
Yeah, I think that's a great idea. We should really step back and look at how language models have evolved.
Right, from those early days of, simple statistical models to the rise of neural networks and then, of course, the transformative power of the transformer architecture.
It's really a fascinating story. And, it's been this incremental progress, but then there's these moments of breakthrough that have just totally reshaped the landscape of AI.
And I think by understanding that historical context, we can really appreciate how MiniMax-01 is pushing the boundaries even further and paving the way for this future where AI can understand and interact with the world in even more sophisticated ways.
Exactly.
So join us in part 2, where we'll delve deeper into those technical details of MiniMax-01's training process, explore its performance on these different benchmarks, and discuss the implications of this research for the future of AI.
Sounds great. Looking forward to it.
Welcome back to Talk Denters. So last time we were exploring that really revolutionary architecture and training process behind MiniMax-01, this model that's kind of changing how we think about AI's ability to remember and analyze information.
Yeah, and we saw how, lightning attention kind of acts as a spotlight, focusing on the most important parts of the input, and then the mixture of experts approach, letting different parts of the model specialize.
It's like having, a team of experts all coming together, each one bringing their own unique skills to the table.
Exactly.
But, all this innovation, it wouldn't really mean much if it didn't deliver in real-world scenarios.
Yeah.
Right? So let's dive into the performance of MiniMax VL01, that multimodal powerhouse that builds on this foundation.
Yeah, so they tested it out on a lot of different benchmarks, seeing how well it could understand images, answer questions about what it was seeing, and even do those complex document understanding tasks.
And what were the results? Did it live up to the hype?
Yeah, for the most part it did. In a lot of cases, it was performing either on par with or even exceeding leading models like GPT-4, especially on those visual question answering tasks. It's really remarkable to see that level of performance from a model that can handle so much information at once.
So it's not just a theoretical breakthrough. It's actually delivering real-world results.
Yeah, exactly.
That's fantastic. But were there any areas where MiniMax VL01 struggled or showed limitations? I mean, no model is perfect. Right?
True, yeah. While it excelled in a lot of areas, it did have some trouble, particularly in tasks that required really advanced mathematical reasoning.
Okay.
For example, on the Olympiad bench, which is specifically designed to test how well AI can problem solve in math. It didn't do quite as well as some of the other top models.
I see. So even with all these advancements, there's still room for improvement, especially when it comes to, these highly specialized reasoning tasks. It's a good reminder that AI is still a developing field with a lot of exciting challenges ahead.
Definitely. And another area where, research is ongoing is in the model's ability to handle even longer context in multimodal settings.
Okay.
While MiniMax VL01 can process a lot of text and visual information, there's always this push to extend those limits even further.
Right. Imagine an AI that can analyze an entire movie instead of just individual frames or short clips.
Right.
And it could answer these really complex questions about the plot, the characters, the underlying themes.
Exactly. That's where this research is heading towards models that can process and understand so much more information from different sources.
It's really moving us closer to a more holistic understanding of the world.
It is.
One of the things that I find really fascinating about this paper is how it challenges what we traditionally think of as a language model. It's not just about text anymore. It's about connecting language with other forms of information, like vision.
Right.
What does this tell us about the broader evolution of AI and the path towards artificial general intelligence?
That's a really great question. And it's something that researchers are really thinking hard about MiniMax-01 with its use of lightning attention, MoE, and that multimodal training. It suggests that AGI might not be about building one massive model that can do everything.
Okay, so not a one-size-fits-all approach.
Right. Instead, it points towards a future where we might have these specialized AI systems, each one really good at certain tasks, and they all work together.
So like a team of specialists, each with their own unique skills coming together to solve problems.
Exactly. And that's reflected in the architecture of MiniMax-01 with that mixture of experts approach.
Where each expert is kind of handling its own little part of the input.
Exactly. And this modular approach, where you can kind of plug in different AI components depending on the task, might be a key to more adaptable AI systems.
It's a really interesting shift, moving away from that idea of a single all-powerful AI.
Yeah.
And more towards this idea of distributed intelligence.
Yeah. And that's also reflected in this increasing focus on multimodal AI.
Right, where models like MiniMax VL01 are learning to process information from multiple sources, just like we do as humans.
Exactly.
It's like teaching AI to perceive the world through different senses, not just language.
Exactly. And as those models improve and get better at handling even longer contexts, we might see this convergence of language vision and maybe even other senses.
It's exciting and a little bit daunting.
Yeah.
To think about AI not just mimicking, but really understanding the world.
It raises a lot of questions, but it also opens up so many possibilities.
It really does. So in the spirit of exploration and discovery, let's go back to the innovations in MiniMax-01 and talk about something that kind of extends beyond the paper itself.
Okay, sounds good.
One of the most interesting things is that use of lightning attention, this really efficient attention mechanism.
Yeah.
We've talked about the efficiency gains, but what are the bigger implications here? Could lightning attention be a key to unlocking even larger context windows and more powerful language models?
That's a question that's creating a lot of buzz in the AI research world. Some people believe that lightning attention, with its ability to scale so well, could be the key to finally breaking through that context window bottleneck that's been holding back language models.
Imagine an AI that could process not just a textbook, but a whole library at once.
Yeah.
The possibilities are incredible.
It's really exciting to think about, and it could change how we interact with information and technology. Imagine search engines that understand everything you've ever searched for,
Wow.
or personal assistants that remember every conversation you've ever had.
It would be like having an AI companion that really knows you.
Yeah.
That's amazing. But are there any reasons to be cautious about all this excitement around lightning attention?
Yeah, I mean, some people are saying we shouldn't get too carried away. They argue that there might be limits to how far we can scale context windows,
Okay.
even with the best algorithms.
So maybe it's not a guaranteed path to unlimited AI memory and processing power?
Right. It could be that there are just fundamental limitations,
I see.
maybe related to the way language works or the limits of our current hardware, that prevent us from getting to truly unlimited context windows.
Like trying to fit an infinite amount of information into a finite space.
Exactly. That's a
Yeah.
good way to put it. And that means we need to keep researching and exploring other approaches too.
So lightning attention might be a great tool, but it might not be the only solution.
Right.
We need to keep an open mind.
Definitely. And that's what makes this field so exciting. We're always pushing boundaries and discovering new things and challenging our assumptions.
It's a journey full of surprises and challenges.
Yeah.
And that's what keeps it so interesting. So let's move on to the novel notions section, where we can explore some potential extensions of this research.
Okay, sounds good.
One question I have is, what if we combined lightning attention with other techniques like neuromorphic computing.
Oh, that's interesting. Neuromorphic computing tries to mimic the structure of the human brain.
Right. Could combining those two approaches lead to AI that learns more like humans do?
It's definitely possible. Imagine AI that can learn from just a few examples,
Wow.
or AI that understands humor and emotions.
That would be a huge leap forward in AI's ability to interact with us in a more natural way.
It would. And it could lead to all sorts of new applications like personalized tutoring systems or AI-powered creative collaborators.
It's like having an AI partner helping us learn and create.
Exactly. But it also makes you think about what it means to be intelligent.
Right. If we can create AI that learns like humans, does that mean it's becoming conscious?
That's a deep question that we don't really have an answer to yet.
It's something to think about as we continue to explore AI.
Definitely. It's what makes this field so fascinating. It's not just about technology, it's about exploring the nature of intelligence itself.
It really is. So to wrap up this part of our deep dive into MiniMax-01, I think we've uncovered some really exciting ideas and potential future directions.
We have. And I think it's clear that this research is pushing the boundaries of what we thought was possible with AI.
It's a journey full of both promise and uncertainty.
Definitely. But one thing is for sure the future of AI is something that we're all shaping together.
So let's continue to explore, to question, and to push those boundaries. But let's do it responsibly, making sure that AI is used for good.
I agree. So thanks for joining us on this deep dive into MiniMax-01.
And we'll see you in part 3 for the final part of our exploration.
Eh.
And welcome back to Talk Tensors for this final part of our deep dive into MiniMax-01.
You know, we've really gone through a lot from its architecture to its performance on all these different tasks, and we even talked about what it might mean for the future of AI.
We saw how MiniMax-01 is really kind of changing what we thought was possible with these language models. It can handle huge amounts of information and even combine language with vision.
And we even discussed how lightning attention could be this key to getting even bigger context windows. AI systems that can process information on a scale we haven't even imagined.
Right. But as with any new technology, these advancements also make us ask some tough questions. Questions that go beyond just the technical stuff and touch on like what it means to be intelligent.
Yeah, it's almost like we're standing at the edge of this totally new frontier, full of possibilities, but also this big unknown.
Absolutely.
Yeah.
One question that comes up a lot is, if these AI systems with all this memory and processing power, could they develop something like human consciousness?
You're right. Could they become sentient?
It's a question that's been around for a long time. Philosophers and scientists have been debating this.
Yeah.
And now as AI gets more advanced, it's becoming even more relevant.
It really is.
If an AI can access and process a library full of information, remember every conversation it's had, and even learn and adapt like humans do, does that mean it's more than just a machine?
It's a tough question, with no easy answers. Some people think that consciousness is just a natural outcome of complex systems. So as AI gets more complex, maybe consciousness just appears.
Okay.
But others think that consciousness is something special, it's something about living beings that can't be replicated in computers.
That's a debate that'll probably go on for a while.
Yeah, probably.
But whether AI becomes conscious or not, these advancements definitely make us think about what it means to be intelligent, what it means to be human.
Absolutely. And these aren't just theoretical questions. They affect how we actually design and interact with these systems.
Right.
If we make AI that's more like us, do we need to think about their rights? Do we treat them differently than we would a regular machine?
It's a lot of ethical and philosophical questions that we'll have to deal with as AI gets more advanced.
Yeah, for sure. But maybe we can switch gears for a moment and go back to something a bit more concrete.
Okay.
In our novel notions section, we were going to look at some ways this research could be extended.
Right.
One area that's really interesting is using lightning attention to help AI understand and create different kinds of art.
Well, that's fascinating. We saw how MiniMax VL01 could handle language and vision.
Right.
Could we go even further and use lightning attention to process and create things like music or paintings or even dance?
It's possible. Imagine AI that could analyze a ton of music, figure out the patterns and structures, and then compose its own original music. Or AI that learns from paintings and sculptures and creates its own art, maybe even working together with human artists.
That's incredible. It would be like having an AI muse helping us come up with new ideas and explore new creative directions.
Exactly. But then it makes you wonder, if AI can make art that's just as good as humans, Does that mean it's really being creative?
Right. Is it just copying what it's learned, or is it something more?
It's a really deep question about what creativity actually is.
And I don't know if we have the answer to that yet.
Yeah, we might not.
But it's something to keep in mind as we explore this connection between AI and human creativity.
For sure. So as we come to the end of our deep dive into MiniMax-01, I hope we've left you with a sense of wonder and curiosity about what AI could become.
Yeah, we've seen how this research is opening up new possibilities, in understanding language, combining different modes of information, and maybe even the possibility of AI consciousness.
It's a journey with a lot of challenges, but also a lot of potential to make a positive impact.
And as we continue to explore, it's important to remember that the future of AI isn't set in stone.
Right.
It's something we're all creating together through the choices we make.
So let's keep exploring and asking questions and pushing the boundaries, but let's do it in a way that benefits everyone.
Exactly. And that's what Talk Tensors is all about. So thank you for joining us on this deep dive into MiniMax-01.
Thanks for listening, everyone.
We'll see you next time for another exciting exploration of the world of AI.